Hello everyone and welcome to this video. Today we will discuss the topic of the stress initialization. We will cover only one method. There are actually more than one method. I think 3 or even 4 methods to do the stress initialization. So in our problem here we have the truck will hit. So in our problem here we have the truck and it will hit this concrete column. And we want to do the stress initialization on this column because we have a load on the top of it. So first of all, I will delete all the parts of the truck. So I can go to I can click on F2. I can click on F2. So I can click on F2, then go to assembly. Then go to assembly, then open the list here, and I have the 1, 2, 3, 4 parts. These one are the one that I want right now, so I can delete the rest. So click on the first one here, then scroll down, and click on the last one, and then right click, then delete parts. Okay, now we have only these 4 parts. We have the green part, which is the column, or we have the green part, which is the column, and we have the solid cylinder on the top, and this is where the load is applied, and we have the beams, which are the reinforcement. And here you can see we have few things which are not being deleted yet. These are the constraint which was used to these are the constraints which were used to link the parts of the truck together. So we need to delete those as well. So I go to keyword and then constraint. We can delete all of this except this constraint Lagrangian solid, because this one is to define the interaction between the reinforcement and the concrete. So I delete one of them. So I delete all of them one by one. You can see it disappeared. Constraint rigid body also delete. Spot weld delete. And if you look closely, we have some green or some blue dots. These are the mass nodes, okay, or the elements, mass elements. If we can click here on the background, we switch the background color. Okay, so we need to delete these guys. I go to element, and as you can see, I only want the solid and the beams, so the rest I can delete. So I don't need any mass elements. Right click and delete. And then this seat belt accelerometer also right click and delete. Okay, now Control and A, I zoom in, so we can see we have only this column which we will apply the force on it. I check the load, so we have the load body Z. This is to define the gravity, and I have load not set. This is the load which is applied on the top of the concrete column. Okay, next I will clean up the keywords. I will delete what I don't want. So airbag, I don't have any airbags, so airbag, I don't have any airbags, so right click and delete. Boundary, okay, we have SPC set. So we have SPC set, we have 2 of them. We can go to boundary, SPC, then we can see we have one on the top and one on the bottom. The one on the top actually we can delete because we want to apply pressure on it, so we can delete that one. So this one hinge at the top we can just delete. we want to define a hinge support at the top. So I will tell you later how to do that. Contact, we don't have any contact. Right click and delete. Control, we need to check few things like time step. We need to check few things like time step. Okay, time step is fine. This erode is 0. Okay, it's fine, meaning we don't have a minimum time. This time step is all the defaults. We need to check the control time step, and we see here we don't have any mass scaling, which is good. We do not want any mass scaling. Control termination, we can set this to be 0, because what we want right now, we want only the stress initialization. Okay, contact we can delete. Shell also we can delete. And we can add one more thing, which is control dynamic relaxation. The defaults is fine. If you want the dynamic relaxation to converge faster, you can increase this one. You can increase this value. You can increase the tolerance, and you can decrease the factor. Okay, so but that might adversely affect the result. So in general, keeping the default values are good enough. Accept. And next, database. Okay, we don't need to do anything here. Define, we have the curves. This is the load curve, and this curve is used in the gravity. So as you can see here, load, body Z, we have this 2 zeros, 2, 0, 0, 0, 0, and 4. And this is the scaling factor. This is the gravity constant. So we don't need to do anything here. Load node set is using load node set is using load curve number 1. And we have seen load curve number 1 is this one. Okay, this value. And right now we want to apply the dynamic relaxation. So how to do that is to change this one from 0 to 1 or 2. Okay, so I change this one to 2, accept. And this is the load which was used for the gravity, 2, 0, 0, 0, 0, 0, and 4. So this one also I change SIDR to 2, then accept. And this, since our termination time is 0, the load should not start from 0. So I can delete this one, and then here also put 0, and then replace accept. When applying the dynamic relaxation and the termination time is 0, we need to have the curve straight. The curve must be constant. Okay, so this is one point that I want to highlight. And the second point is how we apply this load. Okay, wait a second. Okay, so one more important thing that I want to highlight is this value of one more thing that I need to highlight. One more thing one more thing I want to highlight is this value of the load. This value is for the load per node. If I drag here down, if I drag this one here, and then I click on load and node here, and you can see the load is applied on each node. Okay, so this value is actually the value per node, and if I want the total value, and if I want the total amount of the load, and so this load is actually the load per node, and if I want to know the total load, which is this value of the load is the load per node, and if I want to know the total amount of load being applied in a column, I need to multiply by the number of nodes in this node set. Okay, and for that we might have a problem if you refine the mesh, because if you refine the mesh or make the element size bigger, then the number of nodes will be different, and if the number of nodes is different, you need to change this value as well. Okay, so instead of applying load node set, what I will do now is apply load rigid body, because this cap on the top is a rigid body. So I can go to part ID here and then solid cylinder, and degree of freedom is 3. Load curve ID is this one, and it should be negative because it will be applied in the negative Z direction, and I put 540. 540 is the number of the nodes here right now. So then I click on accept and then done. So right now I already take care of the number of nodes, so I can delete. So right now I can just change the part ID here. Okay, so right now I don't need to worry about the number of nodes if I refine the mesh. Okay, because the value of the total, okay, so right now I already multiplied by 450. So right now I already applied by 540, and I already got the total number. So right now now I apply by, so now since I already multiply by 540, I already got the total force applied. So if I refine this mesh of this rigid body number 4, then I don't need to worry about the force. Okay, because whatever applied right now on this rigid body is the total force that I want to apply. So I click on accept and then done. So if this is applied, I need to delete this one. Delete and apply. Okay, now what I want to do, continue cleaning up the model. Right click on rigid wall. I don't need any rigid wall because the bottom is already fixed. Next I go to parts. You can see I have extra parts here. Okay, so I need to delete all of them. This belongs to the truck, so I need to delete them. Okay, now I want to go to parts and see the solid cylinder, the one on the top. So you can see the material number 4 is used to it. So you can see material number 4, which is rigid. So I go to matte, rigid. This is the rigid material. Okay, then accept. Okay, now degree of freedom of this one, I want it to be a hinge support. So what I can do, I put this one equal to 1, which is okay, meaning I will constrain, and then I want to constrain only in X and Y. Okay, so this one should be number 4. The translational constraint is 4 because it is fixed in X and Y. Then for the hinge support, meaning it can rotate only in one direction. in this case it should be rotating only in the x direction. It should only be allowed to rotate around the y direction, okay, because it will bend in this manner. The truck will come in the x direction and it will hit this guy. So for the hinge support, for this the truck will come and hit in the x direction, so the column should be allowed to rotate. The truck will come and hit in the x direction, so it will bend like this, meaning I should allow this column, I should allow this top cylinder here, the yellow one, to rotate around the y direction. So it should be constrained only in the z and x direction. Then I put here 6, accept, done, and continue deleting what I don't need. This initial should be deleted. This is the velocity initialization of the truck. Apply. Okay, last but not least, this is something we need to do. All, and then where is it? Interface, and then spring back ls dyno, and then click on part set. I need to have a part set which have all the parts of the I need to have a part set which consists of all the deformable parts of column. So what I can do here, I can go to new entity, and then I can just put here part set 4, make a new one, and then this is column, which is this one plus reinforcement. So select parts by area and make an area like this, and you can see you have part 1, 2, 3. Okay, part number 4 is a rigid, so we don't need to include it anyway, and then apply. So this part set will be defined, this part set, why we need to define it? It means, so this part we need this part set we need to define it, because we want to tell the software that whatever elements in this part set should be the stress and the strain of these elements should be reported. So this is number 4 actually, and then accept, then done. Now what I can see, boundary control time step we already changed. So model check, see if we have anything. We have warnings. Warnings should be fine as long as we don't have error, then we are good to go. We have some nodes which have not been deleted yet. Click on here on the unreferenced node. You can see these are the nodes which belong to the truck. So again, I can go to element tools, node editing, delete, and then unreferenced all node, delete, accept, and unreferenced element nodes, delete, then accept. And then here I can control save as. What I can say here is stress initialization. Okay, here I need to add one more thing, keyword, and then first I want to check the loads. Okay, this is number 2, meaning stress initialization. This is number 2, which means dynamic relaxation is on. This is also number 2. Okay, before I forget, here I just want to take this factor. Here I just put 1, to avoid the confusion, and I will put that scaling factor here and then accept. So we can just plot here and see, okay, 1.6 mega Newton, this is the total amount of force which is applied on the top of the column. Okay, so this is one thing that we want to do. The second thing, which is load body parts. Load body parts and then part set number 4 and then accept. What does this mean? It means that the gravity load body Z will be applied only to part set number 4, and part set number 4 we have the concrete column and the reinforcement. Okay, we don't have the top support. We don't want the load of the top support to be considered. Why? Because this part is actually just an extra part that we made it because we want to do the hinge boundary condition. Otherwise, our load which is applied on the column is already considered in this defined load curve, which is this value. Okay, so done, and then we click on save. You can see it's already saved here. Okay, so I open this one, browse. This is the guy. Open. Okay, let us maximize the resource. Let us maximize the resources and then run. Okay, we have an error. There are some discrete elements defined. Okay, I can go here, see elements. I don't have any discrete elements here. These are all my beams. Parts, I have only 4 parts. Okay, this one, it says that it has an error, so I can delete it. I don't want it anyway. Save again. Okay, then let us try to rerun. Okay, good. Now it's running. And you can see dynamic relaxation information. This one will not appear if we don't have any dynamic relaxation. This is the convergence factor. The one, if you remember, 1e to the power minus 3. So it will just drop down until it reaches that value. And how much fast it drops down depends on the convergence factor. Okay, and as you can see here, already we reached the termination time, and you can see it dropped to 2.6 e minus 4, which is less the convergence factor that we saw in the control dynamic relaxation. Okay, so I open here. What I'm interested to see is this dyna-in file. Okay, so if I open this one, I can open with the pre-pose actually. And you can see I have the concrete column. I have the elements of the concrete column, and also I have the reinforcement. I have 3 parts, and as you can see here, if I go to if I go to post-processing fringe component, you can see I have the stresses X, Y, and also the stress in the Z direction, and here also the pressure. This is for the solid, and if I want to plot, okay, so this is actually the stresses. The stresses for the beam cannot be plotted here, but they are there. If we go to model, keyword, and then go to initial, you can see here we have strain solid, stress beam, and stress solid. So the stresses in the beam are actually there. Okay. Alright, so what I can do now, I can just close this one and then open it with any text editor. You can use WordPad or Notepad. I will use this Notepad++. Okay, double click here. So you can use Notepad or WordPad, but I will use this Notepad++. Okay, so we have this SPC note set. I don't want that, I can delete. I click on star here and then find next. This node also, I don't want it. Solid element, I do not want it. Beam element, I do not want it. I just only want the initial stresses. So if I go again here and find next, I have this one, initial strain solid, I want it. And then initial stress beam, this one, I want it as well. And then end. Okay, so what I can do now, I can just go up again and just click until I reach this initial stress solid, and I will delete whatever above. So shift control home, then delete, and then this one also delete, and then save. Okay, next what I will do here, I will go to this one. This is the original file that we edited, and I go to file, include. Now I will include the dyna_in file. I have this dyna_in file. I can actually change the name. Let's say stress column stress, or initial stress, whatever you want to change, whatever you want to name it. I go here, keyword, and then include, click on all, include, not initial, include, browse, and then just put it here, browse, open, and then I have this stress, not this one, click on all files, and then dyna_in. What is this? Oh, I changed the name, is column stress. Open, insert, and then accept, and then done. Now I save this one, and if I go here, I open it again. Now it will call this column stress file. Okay, now you can see post process, and then you can see we have some pressure here. I need to hide everything and only show the parts that I want. You can see now we have the stresses. Okay, stress in X, stress in Y, and then we have this Z stress. This is the equivalent stress. Okay, so this is how we do it, but actually we can make it even better. Okay, because these elements, this column has the original length. Due to the self weight and the load from the top, it got some displacement in the Z direction. So we can actually do better than this. What we can do is, I need to open first I will open this with the notepad again, and then include I will need to delete this include for the time being. So I cut and then I save. What I want to do, I will open this one and then delete the column elements. Okay, so I go to here, right view, and then delete, and then carefully select only the column and reinforcement. The top plate will not be in the dyna_in file, so I should keep it as it is. Click by part. Wait. Okay. Okay. Now I delete, and then accept, and then save. Okay. Now I can close this one. Then if I open this with the notepad, you can see it says it has been modified. Want to reload? Yes, I want to reload. And when I reload, after I reload, I click here, and then what I can do, I can take this file. I did not make a copy, so I can go here, dyna_in file does not exist anymore. You want to keep it? Yes, I keep it, and then I save. And then what I can do now, can I control Z? Yes, I will control the I'm doing control Z. Why? Because I want the elements. Okay, in this one I want all the elements, but I don't need the SPC node. Okay, this one I don't need. I just want the elements and the node. So click on home and delete like this is fine. Okay, and I go here, then I paste this one and I put instead dyna_in. Okay, so this dyna_in file has the elements with the has the elements, and this dyna_in file has the elements in its deformed state, but it doesn't have the SPC node, SPC constraint, and that's not important. So now I will include the dyna_in file, which has the elements and the stresses. And remember, right now in this file we just deleted the elements of the column. Okay, so here I can close this one, and I already saved. Now if I open this one, you can see the magic happens. Some warning. Okay, duplicate nodes. It should be fine. Now you can see the column now has the deformation. I mean, the column has the stresses and has deformation as well. If you look from the right view, how can I measure the displacement? Okay, the displacement is very small, that's why it's not very noticeable. Okay, let me check few things. Did it correctly? the rigid, matte, rigid. Okay, I don't want this one. I actually want the stress initialization. I did it correctly. Find load body parts. Okay, fine. And then set load node, SPC. The bottom is fixed, is fine. Matte rigid, and it's fixed in X and Y. So I believe everything should be fine. Okay, so if I measure the if I measure the coordinate here, you can see it's 6,000, which is 6 meters. But if I go here and then I go to measure and then I click here, you can see it's 59999, which is less than 6 meters. So the displacement was only less than 0.5 millimeter. And one more thing that you need to know, that the plate and the column now are separated. So what we can do is we can just show both of them, then duplicate nodes, show duplicate nodes, and then do we have any duplicate nodes? First I want to just show the color. We don't have any duplicate nodes, which means they are already fixed together. Okay, so that's how we do the stress initialization. Let me put the Z stress. Hide everything. Show this 1, 2, 3. Effective stress, and show everything else. Okay, so that's all for this video, and thank you for watching, and see you next time. Bye bye.